Hello and welcome everyone to the KMC Controls webinar on Niagara. We're so glad to have you with us here today. While people are filing in, I'm going to be introing us into this webinar today. My name is Andrew Reynolds. I'm the Video Production Manager at KMC Controls. And we're going to be diving in with our team today. We have Brad Green, Greg Salisbury, and James Johnson is our guest from Tritium. We're going to be talking all things Niagara today, so we're really excited about working through this together and kind of having some great conversations and great questions and just really digging into this material. So on the subject of questions, feel free to ask them as we go through the webinar. Just type them right on in. We may not get to them right as you type them, but we are keeping track of that, and we'll try to answer them as we go along. And hopefully we'll have a little bit of time for Q&A in different spots throughout the webinar. And before we get too far into things, I'm going to put up a poll just to kind of gauge everyone on the experience level with Niagara. So you should see that now, and go ahead and give us an answer for that. I'm going to leave that open for about the next 15 to 20 seconds. We're just kind of gauging everyone's experience level, and it'll kind of guide us on what points we might brush by quickly and what things we're going to keep. All right, thank you guys so much for that. So it looks like we have a pretty good distribution. About 34% are less than a year, 24% 1 to 3 years, 8% of you are 3 to 5, and 34% are 5+. So we got a little bit of everybody here today, so that's great to know. All right, so as we move forward here, I'm going to just move things right on over to Brad to take over. And we're going to get this show on the road.
Thanks, Andrew.
Yep.
Like Andrew said, my name's Brad Green. I'm a product manager here at KMC Controls. And today we're going to start off by going through demoing some just common Workbench features that I like to use that kind of help speed up processes on a daily basis and try to relate them back to what you could use them for, some of your jobs, and hopefully speed up some things. Today I'm going to be demoing in 4.7, Niagara 4.7, and we're using a Jace 8, and it's got 3 BACnet devices connected to it. So I'm going to start off with what I like to use for recent ords, and to show you kind of how that works, I'm going to go through and just click through a couple of these Boolean writables that I have in the sandbox here, and as I change through my views, you can see cycling through 2 and 3 and 4. So in the background, Niagara's always keeping track, and Workbench is always keeping track of where you've been inside of your stations and the ords that you've been to, kind of like a browser history. And so when I'm setting up or navigating through stations, one of the things that can be pretty helpful to kind of know where you were before or set up some tabs to go through to do some commissioning. So I've clicked through these 4 Boolean writables. So I'm going to open those all 4 up in some tabs now. So I can go to File, Open, or File, New Tab. And again, I'm looking at Boolean writable 4 on both my tabs here. You can also just do Control+T, open up a new tab. That's not working. I'll just open up a new tab like that then. Then there's also, if you hold the Control key down and double click on a point, which isn't working either. Not sure why. Okay. Well, you'll just have to trust me that that works. When you hold the Control key down, it will open. So I'll open up another tab. Okay. So now that I have 4 tabs open, looking at all 4 Boolean writables, I'm going to go ahead and change these to set up 1, 2, 3, and then 4. So if I go to my 3rd tab, to invoke recent ords, you can go up to File, and down here there's a recent ords option. And what that will do is present you with the dialog here that you can see your previous places that you've been. So like I said, Workbench is keeping track of these items, and so you can see the different navigations that you saw. I can down arrow, click down to 3, hit enter, and now this tab is set up to 3. Click over to my second tab. You can also get to recent orgs by the menu option here, clicking on that button. And in this situation, I'm just going to hit C to do a hyperlink to that one. So they're kind of indexed down based on letters. So go to my first tab, and now I can hit Alt and space at the same time for the shortcut, and then that'll also bring up the recent orgs. And again, I can use the numeric value here. I can just click it here and click OK. So now I've set up these 4 tabs, you know, for the different Boolean writables. So what I've done with that a lot when I'm setting up commissioning, I'll click through different air handlers or different VAV boxes, and then open up a few tabs, then set them up so then as I'm going through and commissioning things, you can just jump back and forth. Also, as you get in and start troubleshooting things and you're looking on different VAV boxes and different air handlers, and you kind of forget where you were a few steps ago, and you want to navigate back to it, you want to do that quickly. Seen a lot of people use just the back button here. So which this will work. This will take you back to where you were, Boolean writable 4, where I last was. You can go back here, but the benefit of the recent orgs, specifically when you're navigating on a station and you're loading up maybe a PX page or something that's got a lot of points bound to it, and it's gonna maybe be over the internet through a VPN, something like that. It might take a little bit of time. So if you're hitting the back key and you got to go back, you know, kind of like 5 spots, then you're actually loading every one of those pages by hitting the back key. So this is cached locally in Workbench, and that will load up instantly. So you don't have to remember how far back to go. You can just see it in the list. Also in that dialog, you can check the box, show full orgs, and this will show you IP address, so the full org scheme really, so that you can see if you're navigating between multiple stations, and you know, if you're on 2 different IP addresses, that kind of helps you figure out, you know, where to go from there. James, Greg, anything to add for recent orgs dialogue?
If you get disconnected from the station, can you have these tabs pull back up for you?
Yeah, I can show that. So so these tabs where I'm at right now, you could disconnect from the station right now, and it will remember. So here, I'll just do that. Disconnect. Couple things about that is these are already remembering where their org paths are. So if you're just simply disconnected from the station, if you reconnect to the station, and as long as your tabs are still open, they still remember where the orgs are. So you can just use this, which is refresh all tabs, and then that will remember where you were. And like, so I double clicked on the station to get to this. So it was only one thing. I could hit back, but I'm going to use my recent orgs, which is Alt space, and I was on tab 4. So there, now I'm back to having my setup where I have my 4 tabs across. Okay.
Is there a way you could save those if you were commissioning and you came back the next day? And
oh yeah, so if we wanted to, say we were setting up a commissioning for a bunch of VAVs, and these were all VAV boxes, you wanted to save this setup and you wanted to come back into these 4 tabs, you'd use bookmarks. And I like to bookmark all tabs. So we'll just say this, and we'll just call this, this is the Boo writable tabs. So it might be called VAV air handler, whatever you're setting, VAV commissioning setup, click OK. And what that did with the bookmarks is it created this. So the nice thing about that is if you disconnect, so disconnect from here, let's close all the other tabs. So now I'm disconnected, I can go to my bookmarks, and this would even be, even if you closed out a Workbench entirely, you can come back to this open all in tabs. It also gives you the list of the individual tabs. You could just open one at a time. So it's also kind of handy if you just want to go to one. And then, so this will launch, connect to the station, launch all of my tabs. So there I am, nice. 1, 2, 3, and 4. So yeah. Okay, next I was going to show you how to do some bulk adds of some history extensions throughout the station. So I'm going to use the program service to do this. And in order to use the program service, you have to know a little bit about BQL. So before I jump into that, I'm going to show you where to go in the help to find some stuff about BQL. And if I load up my help and search on BQL, find some documentation here about BQL. And this kind of, it goes through how to set up a BQL statement and how to use it. So I'd recommend you kind of look through this as you have time, but not to go too deep into it right now. I'll just kind of walk you through what we want to do. So what we want to do is we're going to go through the sandbox here. We're just going to set up some Boolean COV histories on these 4 points here. So we only have 4, but if you have a large job where you're wanting to set up, a lot of histories on a bunch of points that follow the same process. So when you find objects inside the program service, it's going to open the BQL query builder. First thing to do, especially if you're running against a station that's remote, is you really want to restrict down what you're searching for. So instead of searching in the rooted config, I'm going to drill this down to the sandbox. So just focusing in on our sandbox area, and then you select what type you're going to look for. So for instance, we could search for a control point, and this is going to find any point that extends a B control point. What happens if we do that? We find maybe too many objects, so we don't want to apply to all these objects. Now you could do this in the program service, and you can simply highlight these, and you can remove just the selected ones. So you could use a larger search and remove what you want. But in order to kind of efficiently use the BQL statement here, we're going to look for anything that is a Boolean point that's in the sandbox. So now my search is just going to return my 4 Boolean writable points. So once I have my points, you can do things to these points, like we could edit a slot, we could adjust the fallback value. So if I wanted to set the fallback on all those points to true, that's going to go out and set all the fallback values. You could set other things through there, all the other priority arrays. But one thing that is very helpful is if you add a whole slot. So this is going to add a whole slot to the component. And it's just like how we would use the module palette, where we'd open up a history palette sidebar and we'd select the type. So here's what we're doing in there. We're selecting the history sidebar. So let's select from the history module. And from the history module, we want to pick a Boolean COV history extension. So once we've selected that history extension, we can configure that history extension. So let's enable it. Let's give it some formatted name. Just the default parent name might be enough, but I'm going to add _test just so you can see that these can be changed. Do 250 records. Maybe you want to apply a system tag to it. Any changes you do here, before you add, you definitely want to give it a name. So this is going to be the name of the slot that we're adding. So we're going to call it history. And we've made our configuration changes. We've enabled it. Click OK. And then it's going to give you a result here that it went out and added the COV history extension. So just to show you that, we'll click through a couple of those. We'll just look at this one here and see that. Go ahead. That history was added. It's been configured. It's set up, and now it's running. So if you have a job where you're adding, or you forgot to add histories or alarms on a bunch of points, and you can run through the program service to find all those, could really help speed up some time.
Can you just edit your existing history extension?
Yeah, no, that's a good question. So you can edit a couple different ways. So you could edit just by going into the actual slot. So here's a history, right? We already have the history slot that's applied to all those points that we just added, right? So the cool thing about the edit is we could add the system tag of, let's just add system here. And there is an option. Let's see if I can find it here. Find edit slot. Oh, we're gonna do add slot. So, okay, you can just, if the slot exists, you can just go ahead and just pull up and edit it. You can actually do an add slot again and do the exact same thing. So like we were talking about for the histories, where kind of Niagara keeps track of what you've done, the same little symbol here is on the clock. So it'll say like, oh, you know, you've added a history Boolean COV before, so I can select that. I can also say history. Now maybe I want to make this false and not have them enabled, and maybe I want to make this 800 records, something like that. And any changes like that. Now there's this box right here, which is set if exists. So if that history slot, if that slot name and the type here exists already, do you want to set it? So I'll click yes. So now I can go back, set that, and I've done, this was an add slot that I performed, add slot, but it's actually, it notices that that already exists. So basically what it does is it just calls the set against those. So now my individual histories will be set up. Now they're disabled. Change the history format name, change the capacity type, capacity records, stuff like that.
Is there an undo for the program service?
No, it's a good point. When you start to get into the program service, there's no edit undo. I mean, there is an undo button up here. It's not, it's not highlighted, it's not functional. So as you start to make changes in the program service, you kind of got to be a little careful. I've added, components to other components that really shouldn't be there. You can bulk remove. So like we've added those history slots there. I could remove that slot because I know it's called history. It applies to all these points. So I can go ahead and now all those histories are removed from those, but it will just remove the slot name that's there.
Okay, so it's powerful but dangerous.
Powerful but dangerous.
Always a good idea whenever you do an engineering to make a backup of your application before making engineering changes.
Yeah,
backups are good.
Let me go into spooling right over here. So now that you have seen some of the BACnet stuff, I'm going to show you another navigational tool that I find really useful, and also can be for editing. Say I want to go and I want to look at these different numeric writables, and pretend we're underneath the drivers and we're looking at a lot of devices, and I want to find all of my AHUs or all of my devices that are underneath the drivers, and I'll just do it here. So underneath the drivers, I can use a find. So right click and there's a find. So what this find is going to do is underneath where you're highlighted or where you selected in the nav, it's going to find things that you're looking for. So I could type in Boolean here and it's not finding anything. However, if I did the find here, it's going to find my 4 points that apply to Boolean. So that's just a name. So you can look just based on name anywhere underneath in the find. You can also based on type. So if I look underneath drivers and I do a find and I get rid of the name, and underneath drivers, what I really want to know is, say I want to find all of my devices that are out there under BACnet. So I'm going to go to, you could do this through BACnet, but I'm going to do driver, and then I'm going to say anything that extends a device. So I'm not going to give it a name. I'm just going to say any device that's under there. So find. So now I found 3 devices, and I want to go ahead and make some changes to those 3 devices. So think of a job and you want to commission a bunch of VAVs and you want to go check the temperatures or change settings on them. So you run this find dialog, and the nice thing about it is it's modal, it sits on top, so you can kind of use it as like a navigational tool. So here I'm going to click on my first device. You can notice my content screen over here changed to where I'm just looking at the default view of that device. So if my default view was a an AHU graphic or a VAV graphic, and I wanted to go in and change some properties on there, could just click on it, make my changes, save, double click, move to my next device, go ahead and make some changes, look at supply temperatures, do a checkout, go through the next one. So this can almost become like a checkout wizard, going through and just stepping through and commissioning. Really helpful. You can have multiple open at the same time. So you can open up another find dialog here. And so we can do multiple finds in there. Modal, they're going to just sit on top. So good little navigational tools, very helpful, speed things along.
Where'd you learn some of these shortcuts?
Yeah, of course, from James. And working through, the different tools, just over time, but mainly from webinars like this and listening to James speak at some presentations. So one of the things that James showed to me just the other day was the go into, which I think is pretty cool. I don't use this that much, so I'll maybe let James take it from here a little bit. But when you're looking at a device, you can select a go into, and similar to like what we saw earlier with these bookmarks, there's a folder where it will define the go into statements, where I could go into here. I set up the IP address, but yesterday I did a go into and I just did the station. So the nav tree now is just in this area. I can open up a new nav, and now I can have my whole network, or I can select just my sandbox, which is going to be just where I had that stuff in the station. So those go into seem to be pretty powerful, helpful.
Helps a lot when you're working on larger systems or multiple stations. Instead of having to scroll up and down the nav tree a lot and losing track of where you are, is to have multiple nav sidebars open like that with them narrowed down. So it just declutters things a little bit, makes it easier to manage.
All right, well, I'm going to turn it over to James and Greg, and we're going to all talk a little bit more about some BACnet and tuning and setup there. We'll let James drive maybe, and Greg and I'll ask him some questions about some BACnet tuning.
Thanks, Brad.
Thank you.
So we did have one comment or question, already had a few popping in that we'll try to answer, but with regards to the batch editor, there are some limitations with the batch editor about what components you can add and things like that. So for example, a BACnet proxy point or maybe an alarm extension, although you can add them with the batch editor, it doesn't allow me to configure some of the things like the proxy extension properties or the off normal algorithms and things. If that's the case and you're trying to do some of those batch types of things, it's kind of beyond the scope of this webinar, but the program service, which has the batch editor on it, also has a robot editor, which allows you to write some Java code to do things like that. So it's pretty easy with some scripting to do things like add alarm extensions or add BACnet proxy points or things of that nature as well. So just wanted to clear that up a little bit.
And one other question about finding the host ID of your station. What's the easiest way to do that?
If it's on the installation of like on a PC-based installation, then when you try to start the Workbench up, if it's not licensed, it'll pop up a dialog that shows you what the host ID is, or you can open a Niagara console and type a command to NRE host ID that'll print out the print that out as well.
You could do it from the F3 command and open the console right here on the bottom of Workbench too.
Yeah, the wanted to just show it from the console.
It gets under KMC.
KMC, there we go, thank you. So there's a console icon here, which is the console exe application that will run regardless of whether Niagara's licensed or not. And then you can type in NRE-host ID, and that'll print out the host ID of the machine that you have Niagara installed on. If it's a Jace, then you're going to already be able to connect to the Jace to the platform, and the host ID is there, and as far as on platform views or anything.
Right. Yeah, it's right here in the bottom line here.
Yeah.
Station properties.
Right. All right. So we wanted to talk a little bit about drivers and polling and tuning. Specifically, we'll talk about the Backnet network, since that's what we have set up in the Jace here. And the Backnet network is, I guess, a little bit of a different animal compared to most other networks that exist in Niagara, because of how you set up the network. Typically IP networks either bind to all the network adapters, or you add a network and specify which adapter you want to bind to. So in the case of like a LAN IP network, you'd have multiple LAN IP networks in the station. Backnet's a little bit different in that it has this Backnet COM component, and we have a network layer underneath that. And this allows us to add different ports to the same driver network. So under the Backnet palette, we have network ports that allows us to add additional IP ports, MSTP ports, or Ethernet ports. And each one of these ports also has a poll service underneath it, and that poll service, they all use 2 threads as well on the MSTP, the IP, and the Ethernet. It's a little bit different than most other poll services that we have in Niagara. Most of them only use a single thread. So Backnet is a dual thread to help with the performance a little bit on that.
Can you adjust that number?
That's a good question. It's fixed on a Jace, but if you're utilizing the Backnet AWS or OWS, the Advanced Workstation or Operator Workstation networks, so if you look under your palettes, we have a Backnet AWS and a Backnet OWS, then that property will be configurable on those, which can be used to help some with tuning and performance of the driver potentially.
Great.
So one thing that's common to all drivers really is the tuning policies, and I want to talk a little bit about this maybe before we get into talking more about the poll scheduler. And with most things in software, and Niagara is no exception, there's always defaults to things. Like, for example, everything in Niagara happens at 2 a.m., which is not necessarily the best time to do things, or to do everything at 2 a.m. But we have to have some sort of a default established. And with tuning policies, there's a default policy that's available under every driver. Every driver has a set of tuning policies, and they have each of them have a default policy. So there's probably some things in the default policy which maybe aren't the greatest defaults either. And I think a lot of our customers definitely like to change those default policies. And what we do find, though, in a lot of cases is people will deploy a system with a single default policy, and the default also typically uses a poll cycle time of like 5 seconds, which typically means we're hammering a field bus pretty hard, typically a lot faster than we need to. Things in building automation, temperature controls obviously don't change that dynamically. Typically space temperature doesn't change in 5 seconds. So it oftentimes means that we should set up additional tuning policies to help configure the driver, optimize things a little bit, and that's what we want to talk about here. So the other things in the tuning policies, or some of the things specifically in the tuning policies, are there's a min write time and there's a max write time, and these will help control some of the traffic on the network. What the min write time does is it helps slow down traffic from the station. So if I have something that's changing rapidly in the station that I'm linking out to a field bus, then I can put in a non-zero minimum write time, and that will cause the station to basically queue up those changes in value and only write them after a certain amount of time has elapsed. So there's a example of that would be with this policy we have here, which is the slow write. So we've assigned a minimum write time here of 5 minutes, which that as an example might be a bit excessive, but the idea is maybe if I have a PID loop that's executing in the station every half a second and updating its output, I don't really need to send that signal down to a Backnet controller to reposition an actuator every half a second. So I might put in a 30-second min write time, and that way once the PID loop changes every half a second, but only after 30 seconds do we send a write down to the wire. So that'll help minimize the traffic from the station going out to the field bus then.
What about the read policies there, and then the COV? Like when would it be good to use a COV policy? You know, and should COV policies be set up maybe different than a read policy? Like if I'm reading something fast or.
So COV, Backnet COV is a change of value subscription, and what happens in that case is if the station is trying to read data from a controller, it'll set up a subscription. That's assuming that the controller supports it. So not all devices support COV subscriptions, and in some cases they only support a limited number of COV subscriptions maybe. And if it does support it, and we tell the tuning policy to use COV by changing that property to true, then when that control point is subscribed in the station, we have an interest in the value, then the station will create a COV subscription with the Backnet device. And we tell that Backnet device how long that COV subscription is going to be in force for based on the COV subscription lifetime. So the default here is 15 minutes. Once we send that subscription request, the device will respond with a value, and then it's up to the device to tell me whenever that point value changes during the next 15-minute period of time. So instead of me having to send a read request, the state or that Backnet device just pushes to me notifications when the value changes. So that can be more efficient than doing a request, a polled response scenario. So that's what COV subscriptions are designed to help maybe with that polling time on the network. We will renew the subscription at half the lifetime. So at 7.5 minutes, we renew the subscription. There's still a fair amount of messaging that goes on with COV. If the device supports read property multiple, which a lot of devices do, you may find it more efficient to not use COV and just allow Niagara to send read property multiple requests where it asks for more than one data point in the same message, and that results in fewer messages on the wire and maybe more efficient on the network than doing COV. So you kind of have to do a little testing, a little benchmarking to see how performance works, maybe with trying to use COV or without, and it'll depend on, again, if the device supports it and whether the device supports read property multiple and those sorts of things as well. The max write time is another property that we can tune here, and this is an important one as well. You'll see, like in this rewrite policy example here, we have a non-zero max write time. And when max write time is 0, what that means is whenever there's a change in value in the station will send that command down to the field bus, but it only sends the command on a change in value in the station. A good example of this is like a network command, say occupancy, for example. If the schedule only changes state twice a day, and in the morning it changes to occupied, we send a message out maybe to tell controllers to go occupied. Then maybe there's a power blip or a technician's doing maintenance on a piece of equipment, they turn the disconnect off. change the filters and check the belt and so forth, turn it back on, the controller powers up. Depending on the internal programming logic, it may or may not go back to an occupied state. So there's cases like occupancy or network set point control and things like that, where we want to periodically send kind of a heartbeat signal or command to things to reassert control over it. And that's really what the max write time does. So even though the value hasn't changed in the station will still resend the same message to the wire, to that BACnet device or whatever the field device might be, whatever protocol, it'll resend the same command even though there hasn't been a change in value in the station. So you do want to minimize that. Obviously, you wouldn't want to do that probably on your default policy and cause hundreds or thousands of points to constantly be writing every 5 seconds or 30 seconds or something. You need to take some, consider some reasonable time frames there of how soon you need to reassert control over something, that sort of thing.
So after we create these policies, how would we apply them to the multiple points that we brought in through BACnet? So
yeah, that's a good question. So when you look at the point manager view, is an easy spot to maybe take a look at that on, and it may or may not be showing in your point manager view. In this case, there's a column here which is showing the tuning policy name. If it's not showing over in the right hand corner of the table, when you click on that, you can turn on and off some of the different columns within the manager view, and you could turn on the tuning policy name column if it wasn't already being displayed. So this is showing me what policy certain things are being applied to, and you can edit these on an individual basis. So if I just select a point and edit the point, then I can change that tuning policy name there. If we select multiple points at the same time, then we could edit those, and in bulk we could change the tuning policies. This is also something that you could use the batch editor for. The main thing to be aware of is that you would want to search for the BACnet proxy extension itself and not just for the control point, because there would be properties on the proxy extension that we might not want to edit in batch. We would want to just edit the tuning policy, but that's another way that that can be changed real quickly as well.
On the tuning policies there, I noticed stale time. When would I use that?
That's a good question. I always kind of joke around about having stale bread, right? I've got a loaf of bread that's been in the house for a couple of weeks, and it might have some of that stuff growing on it, that's not going to kill me if I eat it, but it's probably not the freshest and most tasty bread to have. So what stale time is a way to try to indicate that the data in the station maybe isn't as fresh as I thought it might be. So let's say that my normal pulse cycle time is 30 seconds. I might put in a stale time of, say, 3 to 5 times that expected pulse cycle. So maybe 1.5 to 2.5 minutes. And if the station hasn't gotten a value update, gotten a read from that point, and the amount of times elapsed since the last time we got a read exceeds the stale time, then the point status will be marked as stale. It doesn't mean it's down. It doesn't mean we're not communicating with the controller, but it means that we haven't gotten an updated value within a reasonable amount of time that we would expect. So it can be useful. It could be that there's an issue on the bus. It's polling slower than expected. It could be that there's a lot more objects being polled, which is causing the cycle time to be longer. It could be any number of things that might be causing it. I would say use a little bit of caution. A couple of things to consider. A lot of the components in the wire sheet logic have functionality where they'll look at status and might ignore an input with a bad status like stale. So if you're running it into like an average block, the average block might ignore the point value if it has a stale status. So you need to kind of be cognizant of what logic you're doing and what that impact might be on your control logic. The other thing is other than probably putting stale time at 3 to 5 times your expected pulse cycle time, it also really doesn't work with COV because we don't have a real defined expectation of when I'm going to get a value update back. So it really needs to be used in a scenario where we're doing a polled request response kind of scenario. So not like OBIX or Niagara Network or OPC with IO sync updates or things like that. Any of those COV subscription type updates aren't good candidates for a stale time to be set.
So similar to the min and max write time, the stale time, a non-zero value is basically enabled. When it's
Correct.
a 0, it's disabled.
Yes.
And you're not looking for stale.
Yeah.
Okay.
So there's other properties here, which if you're keen and paying attention, you'll see in the default policy, the write on start, write on up, write on enabled are all true. And all the examples of these other tuning policies that we've created in the station, we have those set at false. And really, honestly, those can probably be changed in the default policy as well to false without any negative repercussions there. What those properties control is when the station starts, right on start controls when the station is starting up, that whether it should write all the writable proxy points to the field bus. And in most cases, that's probably unnecessary traffic being generated on the system while it's cranking up, and it just puts an extra load on the station. Write on up and write on enabled have to do with device status transition. So when the BACnet device transitions from a down to an up state, or when it goes from a disabled to enabled, should we rewrite all the writable points on the device? And in most cases, again, that's probably not necessary, particularly if you're implementing a rewrite policy where you have a non-zero max write time set up on something critical, then I need to reassert control of it within some reasonable frequency, right? So having a rewrite policy really probably mitigates the need for the write on up or write on enabled anyway. And then you can minimize some of the traffic on the network, right? When those conditions are going on, we don't have to hammer the network with a lot of unnecessary writes. The other obvious thing there is the poll frequency. So on the tuning policies, you can configure which poll frequency. So we don't have to poll everything under the driver's realm at the same frequency. That will allow us to prioritize polling more important data points that maybe are changing more frequently, like a duct static pressure or a building static pressure, where the space temperature doesn't change that drastically in 5 seconds or even 30 seconds or a minute. But there are some things that might be like discharge air temperature or coil temperatures or things like that that we want more dynamic updates on that we can pull faster, right? Occupancy only changes twice a day, so don't have to pull it that frequently.
So where we see how fast that information's being pulled over the network, like those points?
That's a good question. So what we'll take a look at now is under these BACnet ports, and if it's a different protocol, there's still going to be a poll service that's underneath that network, whether we're talking about LAN or Modbus or OPC or whatever. Then the poll service is going to give us some of that statistics, that information. And it's also where we configure our polling rates, like what our expectations are of what we'd like to see the data update at. And these statistics start from when the station starts up. So you can see the statistics start is listed here. And there is an action on the poll service that we can reset statistics. So if the station's been up and running for a long time and I'm going to start looking at tuning or trying to adjust tuning, it might be worthwhile to reset the statistics, because otherwise some of the information might be skewed in its long running averages. So you can reset that, allow it to accumulate some data for a minute or two, and then start tinkering with the tuning parameters here. It's worth noting maybe that the fast, normal, and the slow rates here, those are just arbitrary names. There's no validation between those. So fast doesn't have to be the fastest and slow doesn't have to be the slowest. They can be set all the same, although there's not really a reason to, I don't think, but the fast could be the slowest one if you wanted to. They're just arbitrary names. The average poll time there, in this case, I always get the funny responses from people when I say, hey, who knows, who can explain what the average poll time is? And somebody will say it's 298.11 milliseconds, right? So, but that is a running average that indicates how long does it take from when the station sends a request message on the field bus until we get a response back. And so there's no right, wrong, perfect answer of what that number might be. It's going to depend on the protocol. It's going to depend on, is it MSTP or IP or Ethernet? is it 9600 baud or 38.4? What's your baud rate? How many router hops there are, things like that. But it's important to have a good idea, an expectation of what that poll time should be on a healthy network that you're installing with the type of devices that you typically install. So check that number on a job is healthy, that you have a good link layer on, you use the proper wiring, the proper termination and biasing resistors, and observe them, max cabling length, max number of devices, and all those kinds of things, and have an idea. It'd be a good indication to you if things are going, if pulse cycles are really slow or long, whether each message is taking a lot of time, a lot of latency, adding to the overall pulse cycle time, and that would point more to probably network conditions, cabling termination, and things like that maybe. Whereas if it's a typical, pulse cycle average time, like maybe 50 milliseconds on this, network that you have, and it's just taking a long time to pull everything, it might just be you're pulling so much data, it's just taking a lot of time to do it, right?
What are good rate? Excuse me. What are good rates for fast, normal, and slow?
It's a loaded question, right? Because it's really going to depend a lot on those network conditions. It's going to depend on how much data I'm trying to pull, and that sort of thing, and how fast those devices are responding. So there's really not one sat answer. One thing you can really look at is the busy time. And that busy time property here, it shows what percentage the threads are busy for this pulse service. How much time are they actually doing something, right? Doing some work of polling something. And it's okay if that gets up to 100%. It just means at that point that the driver is polling as fast as it possibly can for the number of objects that we're asking it to poll, and the poll frequencies and everything. It's spending every bit of time it can to poll all that data. If you see it 100% busy, I would still look at like the Jace's CPU time or the station CPU time if it's on a PC, and make sure we're not overloading the hardware itself, because then we might need to back down on polling and things like that. But you can get an idea. Once you get to 100% busy, your cycle times, which are down here, these are the actual times that the driver is calculating is how long it's taking to go through that queue to pull the things that are in there. You'll see that get longer and longer. I mean, longer than maybe your configured time here, and then you're 100% busy. That's really telling me I've hit that wall of I'm polling as fast as I can, and that's why my cycle time is getting longer, is I'm just polling so many objects at too fast of a frequency, maybe, for what that particular network conditions are allowing and things.
And we have devices on this Backnet MSTP port here that we have 3 devices. There's like 30, 40 points a piece, and they're all configured for different poll rates right now, different tuning policies. But you'll notice the busy time is 0%. So, and another thing about this, it's the point count that's being pulled right now is 0. So even though I have the points in the station, they're there, they're not actually being pulled. So
right, you can add 1,000 points to the station, and that doesn't cause any traffic on the driver. So when the driver wants to poll something is when there's an active interest in that data in the station, and that's what we call a subscribe point in Niagara. And things get subscribed by looking at them, like in a point manager or PX view, wire sheet, or things like that, and those cause transient subscription. And then permanent subscription is caused by having like history extensions and alarm extensions and control logic and that sort of thing. So if I go open up a tab here with some Backnet points loaded on in this point manager view, now we have 31 objects, 31 points in the view. And now if I look at the poll statistics now, we'll see that the point count here now shows 31 points being polled. And this kind of goes back to some of the discussion we were having earlier, is that these counts here are the number of messages which are going out on the wire actually. So we're polling 31 points, but we're doing that by sending only 2 messages right now in the normal queue. So that's using the read property multiple, these KMC devices support that. So the station is asking for multiple BACnet objects in a single request. So instead of sending 31 individual poll requests, we're only sending 2 poll requests and getting all the 31 points of data back. And that's what I was, kind of explaining earlier, is that can be as or more efficient than COV at times. So you have to kind of, test it both ways, maybe, to see how it works on your network.
When would a point stay subscribed and in the point count?
If we have something like an alarm extension, a history extension, a control extension, or we've linked it to wire sheet logic or things of that nature, that's going to put the point into a permanently subscribed state, and it'll always be polled by the driver then. And that's really going to define your base number of points that are always being polled by the driver, even if no one's looking at the system. And that's going to kind of go towards what your minimum cycle time is, right? So if you put a history extension on 1,000 points in your station, then you're going to have 1,000 points in the driver that are subscribed all the time, regardless of whether anyone's looking at it. And depending on the driver and the speed and so forth, that'll kind of dictate what your initial cycle time is, right? And then if we want to transiently look at things in graphics, that'll add more things into the queue and prolong the time possibly. The Dibs, there's a Dibs poll here as well that you see, and not going to get too deep into it, I guess, but the fast, the normal, and the slow are queues. So when points are assigned to that queue, they get pushed into the queue and they're processed by the poll engine hopefully at the configured frequency. And what Dibs is a stack. It's a LIFO stack, last in, first out. So when something first transitions into a subscribed state, a point, it gets added into the Dibs stack, and then it also gets put into its applicable queue. And Dibs has head of the line privileges. It interrupts the polling of the 3 queues, and we pop the stack off the top. So last in, first out. So the most recent thing that's become subscribed is what gets popped off the Dibs stack first. We try to update that information first because that's the UI someone's looking at. And then once the Dibs stack is emptied, it resumes the normal polling of the things that are in the queue then. A little bit of time left here still, right?
Yeah, we've got a few minutes.
A few minutes, okay. So a couple of things, maybe real quick, we'll just show adding a few points to a different policy. So if I add these maybe to the slow read policy, and not saying these are really the right points to do that to, but just want to add a couple of points to some different policies here, just to show what that'll look like in the poll scheduler then. So if I add maybe some of these to the normal read or something like that. What we should see over here now is that now we have 2 messages in normal, and we have a message in slow. We're still polling 31 points, but we're starting to poll some things in some different queues. I guess changing it to normal didn't do anything because default was on normal, so that didn't move to the fast count or anything. When you look at the poll service, you can right-click on the poll service and go to Views and Spy Remote. And when you look at the Spy Remote view, this will give us some debug statistics about the poll service. And just understand these spy views do load static information, so you may have to hit the refresh button to update them. But if we scroll down towards the bottom of this, you'll see that there's some information about the Backnet poll, and this breaks down the actual messages that are going on the wire. And I can see in the normal queue, we have 2 messages that are going out. There's a normal 0 and a normal 1. So in software and Java, things get counted from a 0 index. And this is showing me all the Backnet objects that are being requested in that individual message. That request is going on the wire. So instead of sending 31 individual messages, these are all the things being requested in those individual messages. And you can see here's the objects that are being requested by the slow queue, since we moved some of those points over to that policy. So that can be helpful, just kind of trying to identify some of that. one of the other things that comes up with BACnet in particular is that maybe if I have something that's a prioritized object and I want to command it from the station, so maybe I change this to on at priority 15, then it's still staying off from the controller, and I don't understand why I'm telling it to be on, but it's still off in that case. And you can see that maybe even more clearly looking at the read value and the write value. The station wanted to write this at a 14, but it's still telling me it's reading a false instead of true from the controller. So one of the things that we can do with BACnet in particular is we can poll the BACnet priority, and you can do that with the point facets just by going in here to the point facets, and we can add a new facet here. Now, you may or may not see a priority array listed in your drop-down key here. If not, then you can simply type in here. So you just type in the word priority array with a capital A. So it's lowercase priority, capital A array. It's going to be a Boolean, and then you set the value to true. And what this will do is when we're polling that value from the controller now, it's also going to poll the BACnet priority as well. And it's telling me that this is being controlled at a BACnet priority 9, which is obviously higher priority than what I'm trying to command it at. So that can be real helpful. If you have a thermostat that's writing to the same object or some other other controller on the network, if you're going to implement policies where you do max write times and things like that, then you get the teeter-totter effect or the ping pong where you tell it to do one thing and something else tells it to do the opposite. Then it can be helpful maybe to have that priority array on there as well.
Now, would you want to do that to every point?
Probably not. Obviously, only ones that are prioritized to begin with. So if it's not a priority array point, you wouldn't. And if I'm not concerned about knowing that priority specifically, it's more data to poll. So it is more objects and information to poll. So if you're trying to minimize that, maybe add it where you need it.
Yeah.
Are we looking on time? Questions?
We're almost done. But one question. Can you enable and disable read property multiple in BACnet?
You had mentioned that it's by the device, so devices support it.
Yes.
Is that on the
So if
device?
you look at the device object under a device, then you have protocol services supported here. And this is what the device actually reports, which is why these are all grayed out, right? And I wish they were in alphabetical order because I always forget where they are. But when the device says that it supports the read property multiple, then there it is, read property multiple. Then we'll attempt to use that to request from the device to optimize the messaging. Now, if you want to override some of that behavior, there is a BACnet util palette that's available. And the BACnet util has some device overrides. And one of those is RPM override. You can override the reported APDU size from the device. It reports its own APDU size, and we can tell Niagara, instead of using the reported size here, maybe we can tell Niagara, hey, we want to assume maybe this only handles 350 APDU size, which is the size of the message that the device can accept, whether it supports segmentation or not. And then also there's a services override. So all of that's covered in the help under the doc eng notes here. There's a BACnet and Niagara 4 section, and this has information about overriding a device here. And then under the reference tab here, there's information on the individual components. So we could see basically you're going to add an RPM override to the BACnet device in the station, and then it's just a true or false property. So I could override whether we want to use read property multiple with that device.
So you just drag it on the device?
Yeah, you drag these extensions from the palette These you would just drag and drop them on the device and then configure on an individual device level. That Niagara is going to handle that a little bit differently than what the device really reports, right?
Great. So before we head out, I wanted to make sure everyone knew about some related videos to the Niagara platform. We have a webinar on our KMC Converge modules that are within that and in our Workbench. So definitely check that out and for a much more deeper dive into that. And we also have a video series on our 5051E BACnet router that walks through a lot of diagnostic tools when working on your BACnet networks. And just as a reminder, we do put all of our webinars on YouTube, so this one will also be on our YouTube channel, so definitely check that out there. You can reference all the materials that we talked about today there. And hit us up on LinkedIn, Twitter, Facebook, YouTube, and Instagram. We would love to chat with you more there. Feel free to send us your questions, send us stuff out in the field. We would love to share anything that you're doing on our platforms. We all just want to make things work together and be a big team together. So we want to thank you guys again for joining in. And we thank James for taking out the time to work with us. You will get a survey at the end of this, so please check that out. Give us your feedback so moving forward we can continue to bring great content like this to you. Thank you guys.